Good morning, my name is Amedeo Boldrini and the title of my work is Effects of Microplastics in Marine Organic Matter Production and Transformation. Through the marine carbon cycle, carbon dioxide is stored inside the oceans and later transformed into organic matter. Inside the dissolved organic matter pool there is a fraction able to interact with light called chromophoric dissolved organic matter or CDOM. The amount of this fraction is variable. It can go from 20 up to 80% of total dome, and about composition it is still largely unknown because this fraction is highly reactive with light and microbial activities, and so the chemical composition changes quickly. It's possible to study CDOM with an ultraviolet visible spectrophotometer, and also it can be used as a proxy for studying microbial activities related on organic matter alteration. Two useful parameters to explore modifications on organic matter are spectral slope and slope ratio. Spectral slope defines how rapidly the absorption decreases with increasing wavelength. It can be calculated both with a linear or non-linear fitting depending on spectrum shape. Some examples of CDOM spectra of different waters are reported in picture A, while in picture B there are the respective spectral slope coefficients. Slope ratio is defined how the ratio among two different spectral slope coefficients calculated for two different wavelength ranges. Slope ratio is inversely proportional to CDOM alteration, so an increase on slope ratio means a less altered CDOM. Despite the studies on toxic effect and the role in biofilm formation of different plastic types with different size and shape, to the best of our knowledge, there aren't any study which try to compare effects of microplastics versus inorganic particles. This work was focused on comparing effects of man-made materials like microplastics, which were inserted in the oceans in the last 50 years, versus inorganic particles, here represented by silica, and which are already present in seawater like sand or rock debris from rock erosion. For doing this, two hypotheses were formulated and tested. The first one related to the effects of particles-rich environments versus free particle one. It was expected an increase on microbial processing of CDOM in systems with particles. The second hypothesis is related to the differences on microbial activities in organic versus inorganic substrates. The experiment was divided into two parts. Part 1 was related to the algal growth, where a non-exenic culture of a diatom algae was grown in three different 2-liter flasks. The first one was the control and contained all the algae and artificial seawater. The other two were particles-enriched systems. The first one with polystyrene microbeads, the second with silica particles. In both those last two systems, the final concentration was 200 particles per liter, similar to other values found in seawater and oceans, and the particles had similar dimensions. After 7 days, cell abundance was enough for starting part 2, related to explore CDOM dynamics. 250 milliliters solution from each flask were filtered to remove algae and particles and used to fill 12 quartz cuvettes, which were kept in dark. The storage in dark conditions avoid photodegradative reactions, so in this way any modification on organic matter were related to the bacterial activities. To explore CDOM dynamics, 5 parameters were taken into account. The first one was the absorbance, but this is a bulk index. The other 4 are preferred, and we have spectral slope and slope ratio, already explained, and other 2 ratios, E2, E3 and E4, E6. Starting from CDOM absorption spectrum, two absorption coefficients at 2 wavelengths are used as reference. The first one was at the wavelength 440 nanometers, the other at 355 nanometers. In both cases, the trend was the same. Control in the first position, followed by microplastics and silica, probably related to the fact that control was the less altered system, while silica was the most one. This is confirmed by slope ratio and the slope coefficient. Starting from slope ratio, both control and microplastics exhibited similar trend and values, while silica was different and much lower. According to slope ratio definition, silica was the system with the highest bacterial activity. And this is confirmed also by spectral slope coefficient calculated for the wavelength range 302-322. The two charts are complementary, and despite the opposite trend in the spectral slope coefficient, where silica was in the first position, followed by microplastics and control. According to the definition of a spectral slope, silica was the system with the highest degree on sedum alteration, probably related to the fact that was also the system with the highest observed bacterial activity. In conclusion, according to the first hypothesis, the highest bacterial activity was observed in particles-rich systems, in particular in the silica. This is probably related to the fact that increasing particles concentration lead on the production of a more labile sedum. And as a consequence, there is a faster turnover of dome by bacteria with effects on marine carbon cycle. Thank you for your attention.